All right. Now I need how many significant digits in the final answer?
7.
Well, this is the one that's with the smallest number of digits.
Oh, just kidding.
Of the measured and calculated numbers, this one has the fewest digits. These other 1s and 2s like this, these are all counted numbers here, 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 and here. So only the measured and calculated numbers, this one, and this one. So we want how many digits in the final answer? 3. So we underline from this point over. The leading zero is not significant. And so we're going to round that off to 0.941 grams of sodium sulfate. All right? Does that make sense?
And so, like, on our test, we'll basically do a bunch of problems that takes up a whole page of paper.
Yep.
Like a lot of those.
And we're not even done yet. So, but you'll have plenty of room to do it. All right, so listen. We haven't really determined the limiting reactant yet. Okay? What we need to do is use this number to find it. So here's the rule for you. You ready? Here's the rule. If the amount you calculate of a reactant, the amount you calculate of a reactant is less than the amount you're given in the problem, well, this is less than this amount up here given in the problem, then this is the excess reactant. If the amount you calculate of a reactant is less than the amount you're given, then that is the excess reactant. That makes the other reactant the limiting reactant. Okay? If the amount you calculate of a reactant is less than the amount you're given, so this amount we calculated is less than the amount we were given, then this species, sodium sulfate in this case, is the excess reactant, making the other reactant, and in this case that's silver nitrate, the limiting reactant. Okay? So that means that silver nitrate is the limiting reactant. Okay? So here's the rule if it didn't work out this way. Okay? Here's the rule if it didn't work out that way. If the amount you calculate of a reactant, is greater than the amount you're given, the amount you calculate of a reactant is greater than the amount you are given, then that is the limiting reactant.
Basically, whichever one's bigger, the limiting, the one that's smaller.
I would avoid bigger because you've got to compare it to what? You want to make sure you're comparing it to what you're given of that reactant in the problem.
Yeah.
Okay. If you understand what you're saying, that's fine. Okay. Just be cautious about the application. Okay? So in this case, this is our excess reactant, makes the other one the limiting reactant. Okay? All right.
So that was two definitions for one thing reactant.
Right. Right. Huh? Yeah, pretty much. The second one is just saying, well, what if this doesn't happen and something else? Then you just flip it around.
So if we would have started with sodium sulfate, then
Yes, so the question is, if we had started this calculation, instead of starting with silver nitrate, and we had started with sodium sulfate, we would have found that the amount of silver chloride I calculated over here was a great amount that would be greater than this. And if you don't believe me, try it. You trust me?
Trust you.
I wouldn't trust me. I'd try it. No? Okay. All right.
Yeah, how are we supposed to trust you to teach us for a whole semester if we can't trust you?
Well, okay. It would suit me just fine if you guys tried it for yourself. Okay. Scientists are always, we're skeptical, right?
Yeah.
Yeah.
So it's not going to matter which one we start with on the test?
That's what I said. Well, in the beginning, remember?
Yeah.
I said it doesn't matter which one you start with, because either way, you're either going to get less or more. Now, let me say that with an asterisk, because here's the asterisk part of that. Okay. Let's say that you started with some amount of a reactant, and the amount you calculate over here ends up being exactly the amount of the reactant. Okay? What that means is both of them are the limiting reactant. You can use either one of them in the same way. Okay? They're both going to run out at the same time, so saying you have a limiting reactant kind of doesn't really matter. Okay? Because here's the critical thing. You have to identify your limiting reactant before you can do other calculations we have to do. Okay? So here's the thing about the limiting reactant you need to know. All other calculations will start with the limiting reactant. So we have to make sure we can find that limiting reactant the first time and do it right. Okay? All other calculations require that we first find a limiting reactant. We have to determine it correctly. So let's see. Let's put a couple things together then. That must mean that the theoretical yield must start with the limiting reactant. Okay? Calculating the theoretical yield must start with the limiting reactant. And here's the part that students sometimes get confused. So let me make sure it's as clear as I can make it. When you calculate the theoretical yield or anything that follows this, you have to start with the given amount of limiting reactant, not the calculated amount. Okay? We want to start with the real amount. So in the problem, we were given 2.25 grams of silver nitrate. Okay? That's what we have to start the next problem with, not with some calculated amount. Now that, huh? We haven't calculated it yet.
Then what did you say it starts with?
All right. Over here earlier, I said that there were two kinds of things we'd be using mass-to-mass stoichiometry for. One was to find the limiting reactant. That's what we did here. Okay? The other is to find the theoretical yield. I also said that all calculations following this one must start with the given amount, this given amount of limiting reactant. Okay?
Okay, so after you find that, like when you go to do the next problem, instead of being able to pick one like you could before, you have to use one that.
You have after you find the limiting reactant, then you start with the given amount in the problem of the limiting reactant. Okay, so let's think about the lab just a little bit. In your lab, you measured out the masses of two different chemicals that you then reacted together, correct? Everybody think back to the lab on Thursday. Did you not measure out the masses of two different chemicals? Is everybody, I don't see many heads going up and down. I see a few.
Yes.
Okay. So those two chemicals you started with are reactants. All right? So you have all the tools you need right now to calculate the limiting reactant for your lab. Okay?
Yeah.
That's your homework. All right, now listen. Once you find the limiting reactant, then you know how to start calculating the amount of theoretical yield. Okay? And we can also do that. And I'm going to show you how to start that here in a minute. Okay? How to start that in a minute. All right? Well, we won't finish in class, but it's still mass to mass. The setup's exactly the same. Yep. You may. Yes.
We have to calculate the yield.
Tonight, you'll be able to calculate Tonight you'll be able to calculate, and I'm going to ask you to calculate as homework both the determine the limiting reactant and calculate the theoretical yield. I'm going to show you now how to set up the theoretical yield, okay? It's the same setup. No different, okay? It's 3:15.
So it's basically just what's our close lab.
Huh?
It's basically what it is on the close
Yeah.
lab.
Yeah, but we still have to learn something else before we're completely ready to finish everything on the post lab. Okay? All right. So, let me show you how to set up your theoretical yield then. All right, so up here in our original problem, I said first, number 1, that's when that number 1 was there, what's the limiting reactant? Number 2, what is the theoretical yield? Okay. All right. Now, before we can calculate the theoretical yield, we need to know what we were collecting. So what's the identity of the stuff you were collecting in the lab? Huh? The solid. That's right. You collected the solid, didn't you? So this is not the same reaction as we did in the lab. You were getting a different product. In this case, what amount of product, which one of these two is the thing we're going to collect? The silver sulfate is what I got to collect. It's the only solid there. Okay? It's really hard to collect this stuff because it still dissolves. Okay? We probably could, but we're not far enough along in the semester to know how to do that yet. We certainly can collect this because we can put it in a filter and filter it like you did in the lab, right? Make sense? Okay. So to solve for this then, we need to do a different stoichiometry or mass-to-mass stoichiometry problem. Okay. So in this case, we have to start with the given amount of limiting reactant. The given amount is the amount from the stated problem itself. Okay, not something you calculate. It's the amount in the problem itself. Okay, so we're going to start with that 2.25 grams of silver nitrate over 1. Just like we did in this problem. And then we've got to be able to convert from the mass, using molar mass, going to have to find the moles. Right? You see the pattern here? This step is exactly the same. And you will always have, even if you had started with another species, you'll always have the molar mass. You just have to switch it around. Make sure you put the mass of the starting species on the bottom. Don't forget to cancel as you go. Everybody in here has seen Snow White and the Seven Dwarfs, the Disney version? What's that little song those dwarves all sing as they go to the mountain?
Just whistle while you work, or the high note song.
Okay.
I don't like Snow White.
Okay. How about this version? Cancel as you go.
My childhood. There goes my childhood out there now.
I'm sorry, Bailey. Sorry about that. Okay. All right. Just don't forget to cancel as you go.